Welcome. This is a continuation of the previous lecture. So in this lecture, we'll be discussing about logical and physical address space, and also we'll be discussing about static and dynamic linking. So first let us try to understand what is a logical address space and what is a physical address space. The address space that are generated by the CPU are called as logical address space. And these are also the address space that are used in the program. So the user program knows only about logical address. Okay. The address that are generated by the CPU are called as logical address. The code also knows only about the logical address. Logical address are otherwise called as virtual address because these are not the actual physical address. Okay. The address that are seen by the memory unit are called as physical address. The address that are seen by the memory unit are called as physical address. So if you recall, in the last lecture, we have discussed three types of binding schemes: binding at compile time, binding at load time, and binding at execution time. Okay. If the binding happens at compile time or at the load time, then the logical address and the physical address will be same. There won't be any difference. Okay. If the binding happens at compile time or at load time, then the logical address and physical address will be same. There will not be any difference between the logical address and the physical address. Okay. Because you know where the memory, where the starting address of the program is. Okay. Where the starting address of the code should be loaded. In case of compile time, before compilation itself, you know the starting address. So the physical address will be directly created, or the absolute address will be created. Absolute address is otherwise called as physical address. Okay. So let us note this also. Absolute address is otherwise called as physical address. Okay. Logical address is otherwise called as virtual address. Right. So if you know the, if the compiler knows the starting address beforehand, then it will directly create the absolute code with absolute address or code with physical address. Similarly, if the compiler even if you do not know, it will create a code with relocatable address, and that relocatable address will be obviously converted to absolute address during load time. Okay. So the point is, if the logical or physical address scheme is used, uh, if the compile time or load time addressing scheme is used, then the logical and the physical address will be same. Okay. But if execution time addressing binding scheme is used, but if binding is done during execution time, then the logical address and the physical address will not be same. They will differ. Okay. Is it clear? If the binding is done at execution time, then the logical address and the physical address will not be same. They will differ. How it will, and then how to map from logical address to physical address, that's what here we are going to discuss with a small example. But before that, the set of all logical address generated by a program is called as logical address space. The set of all physical address generated by a program is called as physical address space. Okay. The set of all logical address generated by a program is called as logical address space, and the set of all physical address generated by a program is called as physical address space. Okay. We have discussed, if the binding is done during execution time, then the logical address and physical address will differ. Okay. So there should be some unit which converts the logical or virtual address to physical address. There are many techniques to do that, but here let us see a very basic technique, like how the logical or virtual address can be converted to physical or absolute address. So basically this conversion happens through hardware. This conversion happens through hardware. So there is a hardware unit called memory management unit. There is a hardware unit called memory management unit which will do this process. And for this particular process, Base register will be called as relocation register. Converting what you call a virtual address to physical address, we use base register, but in this context, base registers will be register will be called as relocation register. Okay, so 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 the user program, as we already mentioned, user program deals with only logical address. It never sees the physical address. Okay, so execution time binding occurs when reference is made to the location of the memory in runtime. So what is execution time binding? Runtime binding means, say, say your program is referring to a variable x. Okay. So, so where this x is, that what is the corresponding memory, that location will be decided only at runtime. So that is called as execution time binding. If it is compile time binding, it will be its address will be identified during compile time. If it is load time binding, its address will be identified during the load time. In execution time binding, the variables, the symbolic address will be converted to the physical address only during the runtime. Okay, logical address, or it's not symbolic address, the logical address. The logical address may be, the logical address will be bounded to physical address only during the runtime. That is what is called as execution time binding. Now let us see this, how it happens with an example. Okay, say this diagram shows that, assume that the CPU is creating an logical address 346. So this is the address created by the CPU, which is 346. But now we are using execution time binding. So the actual mapping to the physical address will be done at runtime. Okay. So there will be a register called as relocation register, which is nothing but the base register. So whatever the content in the relocation register, that will be added with the logical address. As a result, what you get, that will be the actual physical address. That will be the actual physical address. So that is what we discussed. In execution time, if the binding happens at execution time, then the logical address and the physical address will differ. But this will not be the case if if the binding happens at compile time or load time. In that case, uh, whether it is compile time binding or load time binding, you will know the starting address in the compile time, in the sense before compiling you know, in the load time in the sense before loading you know. So the CPU will know from which location the address should be paused. So CPU will directly pause uh, of the correct address, that address, so the logical address itself will be the physical address. Okay, right. And so So if you are using runtime binding, the the particular routine will not be called, will not be loaded until it is called. The particular routine will not be loaded until it is called. What does it mean? Assume that you have written a program. Say it may be a C program or a Java program or whatever it may be. Assume the program contains many modules. Like there is a main module from where the program execution starts. There is a main module. Okay, so these are the various modules. Assume there is another module, module 1. There is a module 1. There is module 2. Like that, there are different modules out there. There are different modules, right? Maybe up to there is up to module n. Up to module n are there. Okay. Now now the question is, will all the modules will be loaded into the memory at the same time? No. It means then you are wasting the memory. Okay. So what will happen in the sense, first only the main module will be loaded. Only the main module will be first loaded into the memory. At some point in the main module, it may call module 1. Once the module 1 is called, then it will be loaded. Okay, only when module 1 is getting called, then only its logical address will be converted to physical address. So when module 1 is being called, CPU will send its logical address, and then using this process, it will be converted to physical address, and to the appropriate location it will be loaded. Like that, whenever a particular module is required, then it will be loaded. Thereby, the memory will be utilized effectively. And also, routines will be called only, routines will be loaded only if it is called. Say some routines are not at all called. Say some routines are called based on some if condition. So only if the condition is satisfied, it will be called. Say module 2 is never called, then it will never be loaded. And all other routines will be on the disk in relocatable load format. Okay, that is relocatable means this is logical address is nothing but relocatable address because it is not the actual physical address. After adding with the relocation register, you are getting the physical address. So in case of execution, if execution binding scheme is used, then the logical address is nothing but the relocatable address. Right? And for doing this, no special hardware support is required. It can be implemented through program design itself, and OS help is not much required other than providing libraries to implement dynamic binding. Okay, because anyway during loading the it should be linked with the libraries, right? So we will discuss about that in the next slide. Yeah, here. See this then so in this particular slide we'll be discussing about dynamic linking. So before that, what is linking? Linking means connecting your object code. Say you have written a C program or any other program, but your object code alone it cannot execute because in your program you may be referring some some library files. So those library files should be connected. Those library files should be connected with your program. So connecting your object code with the library files, that process is called as linking. Connecting the library files, connecting the library files with the object code of the user program, that process is called as linking. Now this linking can be either static linking or it can be dynamic linking. Okay. If the loader does this linking, if the loader does this linking, then that is called as static linking. Okay, in static linking means what? System libraries and program code combined by the loader in the binary program image. Okay, so this will be stored. This will be stored in binary format, right? Then only it can execute, right? So if loader does this process, if loader combines the object code with the system library, then that is called a static linking. So loading, so loader, so it means before loading into the memory, you are doing this. Okay, before loading into the memory, you are doing this process, right? So that is called as static binding. In dynamic binding, this linking process will be postponed until execution time, right? In dynamic binding, so loader will not do this linking. The linking will be postponed until execution time. During execution time only it will be linked. Okay, so what does so see, let us see this with an example. Assume that say let us say C code. Assume this is a C code. Int C int C. Here I am using C is equal to power of C is equal to power of x comma 3. So it will calculate the power of x comma 3, that is it will calculate x cube and it will store in C. So before that, here we are declaring x is equal to 9. We are declaring x is equal to 9. Okay. Say the respective header files are added. Hash include math.h, whatever it may be, that is added. Okay. C is assigned with 9. Now what is this what is this power? Power is not an user defined module. Power is a predefined module which is available in math.h. Power is a predefined module which is available in math.h. So you are including math.h in this program. Okay. So already assume math.h is included by using hash include. Okay. Hash include math.h, whatever you right. Okay. So so this power is the library function. So your all these are your code. This will be converted to machine code. This everything will be converted to machine code. But this power machine code is already available, and that should be connected with your program. So that is called as linking. If that is happening at compile, if that is happening at load time, then that is called as static linking. But if this process is postponed, if this process is postponed, to runtime, then that is called as dynamic linking. But how will you postpone to runtime? So this is postponed to, it can be postponed to runtime by using a small piece of code called stub. Okay, by using a small piece of code called stub. So stub, so wherever this kind of linking comes, wherever this kind of linking comes, this, I mean, wherever this kind of reference to library comes, that will be replaced with stub. That will be replaced with stub. Wherever this kind of reference to library comes, that will be replaced by stub. What is stub? What is stub? Stub is, so that will be replaced by stub. Stub is actually a small piece of code that indicates how to locate the appropriate library routine which is in the memory, right? Stub is a small piece of code which helps to locate the appropriate library routine in the memory. Okay, but but if it is, if the routine is already available in the memory, it will help to, it will help to connect with that particular routine. It will, the stub is the one using that the appropriate routine in the memory can be located if the routine is already in the memory. Okay, if it is not in the memory, if it is not in the memory, then stub will help to load the routine, then stub will help to load the routine and then connect. Okay, so stub will perform both the process either way, right? So stub will first check whether that particular library routine is available or not. If it is available, then it will locate it during execution time. Okay, if it is not available, then stub will load that routine and then it will locate to it. Okay, so by this what happens in the sense, say there are many programs, say there are not only one program, no, there may be many program in the memory, many user may be executing. So there is a program p1.c, there is a program p2.c, so like that up to 10 programs or say 20, 10 or 20 programs are there in the memory. Obviously it will not be in C format, it will be in the object code. Okay, so let us say p1.o, p2.o, like that, right? See, different programs may refer to different libraries, right? But but with dynamic binding, what happens? These libraries will be loaded only once to the memory. Only one copy of the library will be loaded, and multiple programs may refer this. Maybe this power may be used by program 1 and also program 2. Then the stub will just locate here. Okay, like that, wherever it is, wherever the corresponding libraries are there, that will be located. But if you are using static binding, then this code will repeat here again. This library code will repeat in P1, it will repeat in P2, like that. Okay, so that is the advantage of using dynamic binding, and that is done by stub. First stub will check whether it is in uh, the routine is already in the memory or not. If it is there, it will just locate. If it is not there, it will it will load it and then it will locate it. Okay, there is something called as shared memory, shared libraries. See, what is meant by shared libraries? See, these libraries will update. It is not that the libraries, once it is created, it is, that's all. No, the particular what you call the creators of the language, they will keep updating the libraries. For example, whatever the library is available in C or Java, they will keep updating. So the new versions of libraries may also be available. For example, some of your program may be compiled with with new libraries, assuming with new libraries, and some of the program may be compiled with the old libraries. Okay, in that case the memory may have both libraries. In that case the memory may have both the versions of the library. It may have new version and also it may have the old version. If a program is using the old version of the library, that will locate to the old version of the library, and if some other program is using new version of the library, then it may refer to the new version of the library. So that concept is called as shared libraries. Okay, so I think the point is clear. The libraries need will not be, it is not that it will never change, it may change. The libraries may change and it may get updated. Okay, so maybe your program sometimes, if it may be compiled with the new library, or some other programs or some other user programs may be compiled with old library. In that case, the program or the stub will refer to the appropriate library. In that case, both the libraries should be loaded into the memory. Okay, that concept is called as shared libraries. Okay, so that's it about logical address to physical address conversion and dynamic linking. Right. Let us stop here. Thank you.